Hello. Now let us look at the second part B of our question. We are still expressing trigonometric expression into a single trigonometric ratio. So now here we have negative 3 sine x minus root 3 cos x. Now we have been told to express them in the form of r sine and r cos. Here I have x plus alpha, here I have x minus alpha. So unless you are limited like here in the question, you've been told what to use, but you are free to use any. You can use sine x minus alpha or cos x plus alpha if there is no restriction. So let us now begin with the first part. When we take r, we shall now consider the negative 3 sine alpha minus root 3 cos x. This negative 3 sine x minus root 3 cos x equal to, let us use r sine x plus alpha. So what we are going to do now is to expand this right hand side, then we equate the coefficients. So when I expand this, I'll be having r, so we shall have sine alpha cos x, then plus, when there's a plus, there's a plus, then we shall have cos alpha sine x, implying that now comparing the coefficients of cos alpha, here the coefficient is going to be r sine alpha, and here we get negative 3. So the coefficient of sine x is going to be this r, don't forget that we also multiply this part here, so we shall get r cos alpha equal to, here I get negative, come again, this is the coefficient of cos x, so the coefficient of cos x is negative root 3, some correction here, negative root 3 is the coefficient of cos x, and this is now, we take this to be the coefficient of cos x, so it is negative root 3, and now that one of course of sine is negative 3, and sine is here, r cos alpha is equal to negative 3. So these are the two equations which will help us to get the r and the alpha, which we shall put here, and that will be our answer. So now if we need to get rid of this r, we shall divide. So equation 1 and equation 2. If we get 1 divided by 2, we shall get sine alpha over cos alpha, which gives us tan alpha. Then we shall get root 3 over 3. So alpha is going to be equal to the tan inverse of root 3 over 3. So our alpha will therefore be, let us check from our calculator here. Okay, we need to get the tan inverse of root 3 over 3. 3 over 3, which gives us 30 degrees. So if we take our alpha to be acute, we shall use this, but don't forget tan is also positive in the third quadrant, where we can have alpha to be 180 plus 30, but we are going to take our alpha to be acute. Now let us look for the R value. Now to find the R value, normally we square the two equations and we add them. So when we square the first equation, we can get R squared sin squared alpha, which is equal to negative, now when squared disappear, root 3 squared will remain with the 3. Then this one will be R squared cos squared alpha equal to 9. So when we add the two equations, we shall get R squared, then sin squared alpha plus cos squared alpha equal to 12. So we know that this is a 1, so we shall get R squared times the 1 equal to 12. So our R is going to be equal to the square root of 12, which can be 4 times 3 inside or 2 root 3. So this is our R, implying that our negative 3 sin x minus root 3 cos x is equal to, we shall write 2 root 3 as our R, then sin x plus 30 for the acute angle of alpha. We know in the first quadrant, you need to note this. In the first quadrant, because here tan alpha is positive, so tan alpha is positive in this quadrant. It is positive here and positive here. So when you have root 3 over 3, that means it is positive, so it is only here where we get 30, and this angle is also 30. So we can either have 30 as our alpha, we can also have 180 plus 30, which gives us 220 degrees. So that can be also, this can be a solution if we take the alpha to be acute. Question at times can tell you that alpha is acute. Or we can also have 2 root 3 sin. Now in situation where alpha is not acute, we need to look for where tan is positive apart from the first quadrant. Now this is going to be x plus 210 degrees. That is also a solution for that. So you need to note this. Now because the question was open, we would like to have two possible solutions between 0 and 360, but there are so many other solutions here. So in situation where we will be, when the question is open, we may focus on the acute angle. So we take this